Hey, ladies and gentlemen, welcome back. Hopefully you guys are all set to go. We're going to look at types of mixtures today. So have your packet, take your notes, make sure you are following along. Pause if you need to fill them in. We have a mixtures reading in Schoology. Don't forget your Survivor project will be due Wednesday the 13th. Speaking of your project, question for today is, what is this? Looks sort of like a ping pong table, maybe a solar collector. Well, actually, it's going to be a method that people use to separate salt or dirt or other contaminants from water. So let's take a look at how this object is used.
F-Cubed is an Australian-owned global company dedicated to the conservation, production and processing of the world's most critical resource, water. F-Cubed have developed and patented a unique solar desalination purification technology called Carousel. Carousel solar desalinating purification technology is the most efficient and cost-effective product of its kind, producing pure, clean drinking water on any scale from any water source using renewable solar energy, emitting zero carbon emissions and zero liquid discharge. This innovative modular panel has the capability of producing millions of litres of pure distilled water per day. Alternatively, Carousel can be used for smaller domestic, rural and village applications. The panel receives impure water by gravity or pump into a feeder pipe at the top of the unit. The input water slowly runs down the solar collector evaporator, being evenly dispersed. Solar energy heats the water, it vaporizes and then condenses on the inside of the specifically designed and treated plastic panel enclosure. Droplets of distilled water run down into a pure water outlet at the bottom of the unit. Carousel, working at an ambient temperature, heats the input water, causing a vapor condensation change, precluding all bacteria and pathogens, therefore eliminating waterborne diseases. Exposure to ultraviolet light and extreme heat from solar energy enhances the germ-killing process. Carousel uses the same natural process as rainfall.
Well, this new material obviously is going to be very helpful for people who are living in a place where they have salt in their water. The way it works is we have sunlight heating up the material here, getting this nice and warm. Water containing salt or other dirt can be put into the top, and as it flows down the panel, it will be heated up by the sunlight and evaporate, which means the liquid turns to gas. Now this top part is covered by a plastic clear coating, and the droplets of water are condensing as they hit the cooler surface, which is clear. Now these little droplets will start to gather together, drip down, and flow out the bottom, giving you clean, clear, distilled water, which does not contain salt or any other contaminants. So it's a great method for helping you clean water. Of course, you may not have this on your shipwrecked island, so you have to think of some creative ways to help you separate salt from water. Many people will go to the next obvious choice, which is a filter, but terrible bad idea. Why? Because salty, sandy water, when poured through a filter, will still be salty. If water flows through, so will salt. When water and salt combine, the salt dissolves, which means it is basically the same size as the water. So any water that goes through will also contain salt. Some people also say, well, let's boil the water. Yes, that kills germs and bacteria, but it doesn't kill salt. In other words, you'll just have hot, salty water. So put everything together. Think about how you can distill water basically on your Survivor island. Today, we're going to learn about 3 types of mixtures. If you don't have your notes packet, get that ready to go. Be ready if you need to pause. We're going to start with the first mixture, which is called a solution. Note the root word sol, so you can think of the word dissolves. Solution, soluble, all have that root word. Solutions are homogeneous, meaning you can't see the parts. Where something dissolves. There are many examples. Salt dissolves in water, as well as sugar. But gases can dissolve in liquids, such as carbon dioxide bubbles in your cola, or gases in other gases, like oxygen in the air, which is mostly nitrogen. Solutions contain dissolved materials. If you look at something like the food coloring here dissolving in the picture, you'll notice that it's evenly dispersed, homogeneous. Now there's 2 parts of a solution. Obviously there's the material that is the main part that does the dissolving. That's called the solvent. We still have that root word. Solvents are materials that can dissolve something else. If you think of an obvious example like salty water, water's the solvent. A solvent is a material that can dissolve something else. Water here is surrounding and dissolving another material. Water is the universal solvent, but it's not the only one. Alcohol will dissolve a permanent marker. Paint remover will dissolve paint. Solutes are the materials that get dissolved. Again, we still have the sol root, so you know that a solute, U, getting dissolved, is a material that gets dissolved by the solvent, like salt or sugar or any material that can dissolve. Notice in our example, water and salt sugar particles are about the same size. That's why they're so difficult to separate, and filters usually don't achieve separation. A second type of mixture that is very common is a suspension. These are heterogeneous mixtures. That means you can see the parts because the parts of the suspension are larger and insoluble, and they may suspend for a short time but settle out, perhaps due to gravity. A good example would be a mixture of sand and water. If you stir up the sandy water, the sand will float around in the water for some time but then settle out. Oil and water is another kind of suspension using two liquids that eventually will separate. In this picture, sand and air are mixed, but given time, all the sand will settle out. Think of a snow globe or any kind of material that you have to shake up. Sand in the air, similar to snow in the air. There are many other kinds of suspensions. They often say shake well. The reason is they don't stay mixed. So medicines must be shaken. Mustard is another example. Colloids are mixtures that fit somewhere between solutions and suspensions. They're kind of that middle ground. The solids remain mixed in the liquids. However, they're not dissolved. They're homogeneous, whereas you can't tell the parts or see them, but they're not technically dissolved. You can't see through them like you could a solution. They scatter light. Milk is a good example. You can't see through it. It's homogeneous in that you don't have to shake or stir it. However, the particles are larger. Milk, blood, jello, fog, many kinds of paints. Those are all good examples of colloids, with particles somewhere in between the size of a solution and a suspension. Let's take a look at a quick review, and then you can begin your mixtures reading in Schoology. It's also in your packet if you'd like to read along, but make sure you submit it in Schoology. Let's take a look at the mixtures review for today's notes. And hopefully, by looking at that, you'll understand everything there is to know about mixtures.
Mixtures: chicken soup, clouds, cookie dough, mud, cereal, gasoline, blood, coffee, concrete, sand, your favorite soft drink, even the air you breathe.
Mixtures are a combination of two or more substances that do not undergo a chemical reaction. Mixtures can be any combination of solids, liquids, and gases.
Italian salad dressing, for example, is a mixture of all three.
You can see the herbs, the solids, and the air bubbles, the gas, mixed in with the oil and vinegar, the liquids.
The components of mixtures can be separated through evaporation, through gravity, or through other mechanical means. Mechanical methods of separation can be as simple as picking olives off of a salad, using a filter to clean the air,
or using a magnet to separate iron filings from sand. Some mixtures can be separated utilizing specialized equipment. For example, a washing machine removes water from its load by spinning. Similarly, a centrifuge forces denser substances to the bottom by spinning a sample very quickly.
There are two kinds of mixtures, homogeneous and heterogeneous. These names are based on the Greek root words, homo meaning same and heteros meaning different. The components of homogeneous mixtures are uniformly distributed, whereas the components of heterogeneous mixtures are not.
Mixtures like oil and water, cereal and milk, and salads are called heterogeneous mixtures. The components in heterogeneous mixtures are unevenly distributed. Components may be as large as lettuce leaves in a salad, or as small as water molecules in an oil and water mixture.
One example of a heterogeneous mixture is when we put food coloring in mineral oil. The food coloring remains in the form of droplets that settle to the bottom of the container. The two components are not distributed evenly and make a heterogeneous mixture.
There are many different kinds of heterogeneous mixtures, including suspensions, which are solid particles in gas or in a liquid that settle out due to gravity, like sand and water. Another kind of heterogeneous mixture is an emulsion, which is a combination of two different liquids that separate out from one another, like oil and water.
Homogeneous mixtures, on the other hand, have an even distribution of substances throughout. Everyday examples include coffee, salt water, and homogenized milk.
The substances in a homogeneous mixture tend to have smaller particle sizes than in a heterogeneous mixture. In some cases, the particle size is too small to be distinguished from the other substances. Notice how the food dye distributes evenly throughout the water, forming a homogeneous mixture.
The food coloring cannot be distinguished from the water in the same way that dissolved sugar cannot be distinguished from coffee. Although they cannot be seen, both substances are still in the mixture.
There are many different kinds of homogeneous mixtures, including solutions and colloids. A solution is a homogeneous mixture whose components form a single phase. In the case of sugar and water, you can have a solid dissolved in liquid, but the outcome is a single-phase liquid. Colloids are mixtures where fine particles are dispersed throughout another substance and tend to have a cloudy appearance, like milk.
To recap, a mixture contains two or more substances that are held together by physical forces and do not create a new substance. Mixtures can consist of any combination of solids, liquids, and gases.
Mixtures can be separated by many approaches, such as evaporation, gravity, or mechanical means.
Mixtures can be heterogeneous or homogeneous. The components in heterogeneous mixtures are unevenly distributed, whereas homogeneous mixtures are evenly distributed. So now you know.
All right, guys, thanks so much for checking this out. And go ahead and make sure you do your homework. And hey, thanks so much for trying science. We'll see you next time. Bye for now.